The next question you can be asked is, what is the gradient of the line joining those 2 points? The gradient of the line joining the 2 points. Now, of course, we could draw it, but what is gradient? What's the standard thing for gradient? Rise over run. Okay, now, funnily enough, we've just come from this formula, which was d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. And what do you think x1 minus x2 is? And y1 minus y2, what is that? Well, yeah. Yeah, I mean, y1 minus y2 is the rise, and x1 minus x2 is the run. Isn't it? Because it's the length of those sides, the same point. So if I just drew this one, just so that you can see, we've got to be a little bit careful with the signs because we're not squaring anything this time. But if a is 6, negative 2, which is here, okay, so that's 6, negative 2. That's our A position, and B is negative 3, 11, which is over here somewhere and way up here, we'll put it. Negative 3, 11 is way up there. Now, if you actually have a look at this drawing, I'll just use this pen because I don't, oh no, I'll try that. That line, now you can see why, it's pretty easy to see when we draw it, that the distance is across the bottom here, from here to here, is a total of 9 because, well, it is. It's 6 and the negative 3, the difference between them is 9. And the distance from our horizontal from here to here is a total of 11 plus 2, which is 13. So you can sort of see why 9 squared plus 13 squared is going to give you the distance for that one. But we don't want to draw it all the time. Okay? So what we've got to do is we've got to get a consistent way of writing down the rise, a consistent way, and so that we can get the gradient. The gradient, of course, is the rise, which is that much, divided by that much. But the sign is critical because what does the sign do for our gradient? Yeah, positive or negative. This guy here has to come out to be a negative line. Okay, if we just say the rise is 13 and the run is 9, 13 divided by 9 gives us a positive number, and that's, of course, it's not the gradient. Okay, so what we do is we say the gradient, and it's given the letter m for gradient, from y equals mx plus c. I don't know why it's m, but there it is. It is m. The gradient is the rise, which is y2 minus y1, okay, over x2 minus x1. Or the other way around, or y1 minus y2 over x2 minus x1. And we'll very quickly see why it makes no difference. So let's stay with consistency here. Y2 minus y1. Let's make A x1 y1, B x2 y2. Y2, here it is here. I'll draw a whole lot of lines on here that will disappear. Y2 take away y1 gives us 13. Okay? So doing it y2 minus y1, we get 13 over x2 take away x1, negative 3 take away 6, negative 9. 13 over negative 9, it's a negative, it's the 13 over 9 with a negative, which is what we want. Okay? Now, I'll write this down shortly again. If we did it the other way round, and we went this one minus this one, instead of the other way round, we went A take away B rather than B take away A, then on the top line here we'd get negative 2 take away 11, which is negative 13. So that take away that gives us negative 13, and 6 take away that gives us positive 9. It still comes out positive. which is exactly what you'd negative, which is exactly what you'd expect. So the short answer is we pick one. We can pick y2 minus y1 over x2 minus x1, or if we want to go with numerical order, y1 minus y2 over x1 minus x2. It absolutely makes no difference. But it's rise over run. Again, a simple concept, rise over run. But of course it's critical to get the sign right. So I like that. For some reason, y2 minus y1 over x2 minus x1 is just how I was taught it years and years ago, but how I've sort of always just remembered the gradient for some reason. But if we go with this, that will give us, for this question, the A and the B question, end up with 13 over minus 9. And of course, we wouldn't leave it like that generally. We would. Convention suggests that the negative sign should just sit out the front or be on the top line, but not on the bottom line. So that's basic gradient. Very, very straightforward to work out the gradient. Okay, now just before you go,